Hey everyone, in today's video we are diving into one of the most essential libraries for machine learning and deep learning, which is TensorFlow. So if you are aiming for roles like data scientist, machine learning engineer or deep learning engineer, then understanding TensorFlow is a must. We will walk you through how TensorFlow works, starting with the basics like how to set it up, use constants, and perform mathematical operations. And by the end of this video, you will be ready to start working with TensorFlow for your own machine learning projects. And also, if you're excited to dive deeper into AIML, don't forget to check out our free masterclass on AIML and Agentic AI. It's a great way to boost your skills and prepare for high-paying roles. In the masterclass, we will discuss a proven 3-step framework for landing your dream job in AI and machine learning. Professionals like Utkarsh, Shrija, and Debashish have used this roadmap to secure top positions. The registration link is right there in the description box as well as in the pinned comments. So now let's jump in and get started.
All right. So let's start talk about the TensorFlow basics first, then we will discuss further things. Right now, like you can know, like here, if you want to know about the TensorFlow, you need to import the package. And to import this package, once again, you need to write down TensorFlow. It is just like similar as we used to write import NumPy as NP, import pandas as PD, and so on. And before that, like it will be by default install if you're working in Colab. Like in case if you're working somewhere else on other platform, you can use this pip install TensorFlow. So pip install is the basic thing like that you will be doing, and then after packaging. Sometime if it's not working, add the exclamation symbol, right? Then after you can just start executing, and you will see, like in my case, it's already satisfied. Then after, if I want to use, I can take the alias name as tf. So I need to write my import TensorFlow as tf. Once again, guys, I have already included everything here because I didn't want you to waste time in typing because it takes more time. So I already included everything here. So you can see, like you have to import the package. Then after very first, we want to know the version. So once you will see the version, you will find that is 2.18.0. As we discussed, this is version 2. While we had version 1 earlier, but that was not successful because we need to start the session each time and many other restrictions were there. That's why version 2 is more interesting and more easier. So here, in case if we want to hold the values, we need to bring my constant values. So for constant, like here, we have our data. So right now we have taken the 2D data. Like if you will see this, so this is nothing, this is 2D only, right? Once again, we have this 2D. And how can we take that? 2D means collection of 1D. So you had 1D, 1D. So once you have the collection of 1Ds, we normally call 2D. So right now we have 2D. How I came to know? Even I can also check it with the help of number of brackets. We can see number of brackets in the beginning is 2. That's why it's 2. But right now, it doesn't matter like any type of data you have, 1D, 2D, 10D, doesn't matter. So, but once, whenever you want to use this one in your models or in your TensorFlow, so you just need to bring it as a tensor. What is tensor first? Tensor means like you have again more than 2D are there. We normally call tensor. We'll discuss once again about that, like what are the different things. But right now, I just need to convert my tf.constant. This is the method name that I need to use. And once I do, I am able to see this object, right? If you will focus on this object, we have 3 important things. The shape. As we discussed, we have 2 rows and 2 columns, right? That's why the shape is 2, 2. While dtype is each element is of int 32, right? Integer 23, 4, 32, 51. So int is here and by default it's taking integer 32. For getting the each value, we need to use NumPy. NumPy is here not the package. It is the you can say the parameter here and the actual value of your NumPy internally as we discussed the NumPy is here. Means this complete package is built upon NumPy. Right? So this is the important package for all other different packages that you see. This is why here you will find all the actual value will be here as a NumPy over which you will find the wrapper. What wrapper? after making more attractive, they make a new package to which they call TensorFlow. But this is also very popular because if you want to develop your machine learning or sorry deep learning solutions, so we normally use TensorFlow or some other package. But TensorFlow is one of the popular one. So you can understand. But what I want to say, like if you remember, like a few years back in India during the festival time in Diwali, especially. So during that time, we find a lot of products are there. But when you will remove the wrapper, especially some cookies were there, I remember like I used to see when I removed the wrapper, I found Britannia, and in the front it was some other name, like some other brand was there. So big brands are also copying. Like I saw, like this cookies seems to be like the same, like that we have. But why I'm talking about this example right now? Because they had the same product, but above that they made their own attractive packing only. They add some wrapper or some other things and made their own product. So that is something like they we also used to see here. Like internally we have that ND array of it. ND means numpy. Above that you added new features, you added new things, and you got that TensorFlow. So you can just check it out. Like here, we have the TensorFlow, but I mentioned three important things. But we'll talk about that thing once again, like what threes are there. But with that, you can see I was discussing about TensorFlow 1. Why it was not popular? Because in case if we want to make this kind of a variable or constant, again, we used to use the same thing, tf.Variable. And we had this data. And you will again get that variable, but you will not be able to access this variable till you will not start the session. So in case if you want to access anything, your session must be started. So there were a lot of confusion in the beginning time because it was the initial phase of this deep learning thing. But we people also got very confused in the beginning, like what to do, and it was not easy for learning. Then later it was converted again back into this TensorFlow 2 and things become easy. So during that time, what we used to do, we need to initialize the session first. And for that, first it should be started. Then after within the block, you need to do other things. You need to run the session. And then after you used to eval the session, then you will be doing any other task. So these kind of things were there that we used to do in TensorFlow 1. But you don't need to worry now, right? We don't need to do all this stuff. So TensorFlow 2.0, like the future has not been kind to you, has it? Like it was the past thing. Now we usually talk about TensorFlow 2.0. So here you just need to import your package, right? As we have discussed earlier as well. And as we know, like this is 2.18, which is the latest package of this TensorFlow. Right now, as we discussed, some links are already given above to know a little more in more detail, like what TensorFlow. If you want to deep dive into other topics as well, you can go into their document, the official website, and you will find this side many other things. So this side you have the beginner, like where you can find the machine learning and other things. In advanced as well, tensor operation, distributed training, and many other things related to different operations. Right now, we don't need to discuss about a lot of things in detail, but first we need to understand the fundamental. I think this file can help you a lot to get enter into this world, and I have included many things as fundamental. But right now, let's start with talking about this TensorFlow with constant and variables. So in case if I need to talk about these constant, here we have again some data as I was discussing earlier. Like we have some data set with us, not data set exactly, but yes, some basic data with us, right? So again, once I'm going to use this data, you will find this is 2 into 2, right? And I am just going to convert into the constant. And we will get this tensor 2. Again, I'm going to see this shape is 2 by 2. And data type, since we had the integer value, we got 32 by default. And my actual record are lying here. Array 2, 3, 4, 2, 3, 5, 1. And by default, as we discussed, like this dtype is integer 32. Now, when you see this tensor object that you got as a result, definitely it's a tensor object. It's not numpy, it's complete as tensor. You can remember that thing. Internally, we have that, this NumPy object, but now total, this complete is my tensor. So guys, right now we got my tensor object, right? This was my tensor object. Now I want to know each and everything separately. We can get that thing as a parameter. We have the shape parameter. I just want to know, okay, like this was my tensor and I want to know about the shape, right? So I can get that thing shape only, which is 2 into 2 by 2, right? Why it was 2 by 2? Because this kind of 2 rows, 2 columns, right? We got that 2 comma 2. Similarly, if you says I want to know about this object was here, tensor object, in which we wanted to access only the shape, we said object.shape, we got that result. Similarly, you says dtype, you will get that. The object.numpy, you will get the actual decode. Just like you are doing in the next case, you want to know about this numpy, make sure you need to add the bracket, means it's a function. So here, if I want to know about that, I will get the actual decode, right? So once you are going to get that TensorFlow object.numpy, you got the actual decode, right? I do some changes once again. So for example, this time we had 2 comma 2. I am going to do some changes here, right? And right now I have the tensor object right now with me. All right, so here we had the tensor, and in which once you will check that, we will see the shape as 4 comma 2. And here you can see the actual record, that is numpy. I just want to emphasize internally it is anti-array object, right? And to get that thing, you can access the shape, you can access the numpy as well as dtype as well. But once you see this, like we want to extract the numpy. Hey, it was the 4 records, 4 rows were there, but now it's 2. Re-execute. Now I got the 4 records. That means 4 rows and 2 columns, right? With that, I want to do the one more changes. I say this is not 32, it is 32.0. Will that be okay? Will that impact in my result? Means this change can impact into my result. Will I see some changes in my result? Why I'm asking you? Because as I mentioned, like this is based on NumPy. And I'm expecting you guys are aware about NumPy as well. So once I will see a small difference, you could say, yes, definitely, like it's 32.0. Now it was 32 earlier. So you will see one small difference here. But apart from
Data
that,
type will change.
yeah, because it was in 32. And as you will re-execute, it becomes float 32. What it do? Talk about this internally, what it do? We have every element of same type. It will not be different. It will be of same type like this. Like in case we have all the values are integer, so you will see in this case, every element block will be integer. If one is float, which is the bigger number in comparison to integer, so every block, each block will be of float type only. Getting? Make sure I just want to emphasize internally in NumPy what we do. We have each and every element is of same shape and same size. Right now, when you say it's one is the float type, which takes a little more, which is more than integer. Internally, every single block, how many elements are there? We have 8 elements are there. For each element, it will allocate the same memory, same space, and same shape. Means it is just like that, like a new colony where each house is provided by the government, and for each house you will find the equal number of space, equal number of rooms, bathroom, and everything will be absolutely same. We have 10 elements, 10 houses are there, everything will be absolutely same, just like we used to see in the government colonies, right? Similarly, in the NumPy also, it just do the same thing. Like if one is integer, everyone will be integer. One is a bigger number like float, so in that case, each element will convert into floating point only. So that is why you are watching like only one element was changed as float value, dtype have been changed into float 32. Now once we have tensor object, out of tensor we were extracting the shape, we were extracting the numpy, which is nothing, actual value, right? We got that. This time it's 4.8. Now when I see this, like I was holding that value as numpy into nd. And now once I see this nd, you will find numpy.nd. So here you will find like it is of nd array object. Means internally it is numpy only, right? So you want to convert numpy array back to TensorFlow. So let's say like I just want to talk about nothing. Like I read, let's say we have this one as nd array object, numpy object, right? We have 23 something data, but if you remember numpy, what we used to do? We used to say import numpy as np and numpy.array. We are going to provide the data into the numpy object, and now we're going to get that. Now my requirement is that this is numpy object. I want to convert this numpy into TensorFlow. Can I do that? Yes. tf.constant. I will pass this numpy TensorFlow object and we will get that. Right? Once again, we got a new tensor object, which is of shape 2, 2. We have this time integer. Everything was integer here. We got integer 64 and the numpy actual value is this. Right? Yeah. So now we have scalar. Scalar means like only a value. In this case, you are not watching 1D or 2D, but a simple value is here to which we say scalar. Now when I execute, you see that like here we have numpy 7 again. Shape is nothing is given. That means you will find no dimension is here. And since it was 7 an integer value, so by default int 32. So once you see, we have this. You will make it 79, 70, 790, any value you will find. Only value have been changed while shape and integer is same. Now, once again, out of this, you want to extract the different value. You can get that out of this object. You want to know about n dimension. So 0 means it's scalar, right? It's showing 0, that means scalar. Once again, if you say instead of scalar, if you want to make 1D, you can do that. Here we have the shape 2, what does it mean? So you can just check it out. We have only two values, not null value. We have two values out there. That's why it's showing 2, that means it is only 1D because we have only single element here. If it will be 2, 3, that means 2 rows, 3 column. That could be the shape as we did the very first 2, 3, 3, 2, right? You were talking about that, right? Now 2, let's say I am going to make it 3. Now you see the change, 3, right? You say it's the same kind of a change. In this, it was 3, only 3 elements were there, but now I want to make another one. I am making 2D. Can you please expect, like in this case, what should be the output? We have 2, 2, 2 rows and 3 columns are there. So 2, 3. Right? The shape was 3, because we had only 3 elements were there. But since it was 1D, that is why only one element. But this time it is 2D. That means 2 rows and 3 columns. That's why we got 2, 3. Right? With that, what was the data type? We have all integer. That's why int 32. What is the actual values are there that we can find in numpy? Next, we have ndim. We want to know about vector.ndim. Earlier vector was 1D, now it is 2D, right? So yes, nd means number of dimensions. How many dimensions? We have 1, 2. You can also check it from here. We have 2 values, two dimensions are there because this is also one indicator. In the beginning, you have the 2 bracket. Otherwise, you can see it's a collection of 1D, that means it's 2D. In other word, what is 2D? 2D means collection of 1Ds. I discussed scalar, vector, and now we have matrix. We know about the matrix here. So we also call that one as matrix. If I am going to talk about this was only the vector here, not this one, I would not say this is my vector. This is matrix basically. So I'm just removing. I included that example just for explaining. Matrix surface in which we have at least 2D, right? In the above one, we had only 1D. I hope everyone is clear with that. We totally understand what is scalar, a single value, vector, that kind of a value where you have 1D only. When you have 2D, we call matrix, right? Now you can see we have the 2 by 2 elements, that is matrix. If it is 1D, we have vector, right? Now, in this case, again, the same story. We have shape 2, 2, dtype all are integer, that is in 32, and the actual values we can find by numpy. Only value we normally call scalar in maths, while we have vector when you see 1D. So this we call vector, either that is in this shape or in a single column. But whenever you have more than 1D, that means 2Ds are there, not more than 1D, it will not be the right. In short, when we used to talk about the 2D, just like in maths, if you remember, we used to do a lot of matrix calculation, right? So you will find that matrix. Why we are discussing about this kind of stuff? Because guys, whenever you will play with real-time data, you will encounter with these kind of mathematical issues as well. And internally, whenever especially we play with images, videos, we need to know about these matrices. We need to do some calculation here. And for doing that kind of calculation, this package will help you. No. 2D was not vector. I wrote that thing. I mentioned 2 times. Like I was talking about that vector, but I was talking about, just for explaining, I included one more. I was just trying to show the shape. That's why I included that thing. But I repeated 2 times. Like this is vector when it is 1D. So right now we have this another matrix is here. We are going to include here. So once you see this, in this case, again, you can find since 10 dot, 3 dot, that means floating point value. And by default, it is taking float 16. Why? Because manually we were passing it. In case you are again creating that one without mentioning this dtype. So what should be the dtype of it? Dtype was by default float 32. Right? As we discussed earlier, like it was float 32 earlier as well. But now manually we were passing like dtype should be tf.float16. Since values are small, why I need to occupy 32 bits when I can work into 16-bit? What do you think, guys? Is this really important to convert that? It's okay, like only 16 bits are there. Is this important? Think about it. We are talking about 16 bits only. That is not a big deal, like once you are playing with this data. But this data is in millions. Data set containing millions of record, trillions of record. Then 16 bits really matters. So it should be the story, like if you can start working with a less number of space, why should we go with the larger space? Like, why should I spend 16-bit here? So definitely, yes, it's saving the space. Not only space, whenever you will start the calculation or you will do some kind of processing, that time also it matters a lot. Because you will be spending more computation power, more time, and that will be equal to money. It will be equal to cost as well. So that's why we should pay attention on small things. Like in case if I can handle my data in less space, why should we occupy the more? Right? I can see we have the small values are there in my whole data. So it could be go with float 16, and that we can do with the help of dtype. Yes, it is for performance improvement. Yes. Right now, guys, we have this another metric that we have taken. Again, want to check about enddim. Here we have the 2D since we can see 3 rows and 2 columns. So we have this 2D and enddim is 2 of them. So we discussed few things here. We discussed scalar, vector, and matrix. Now, whenever we have more than 2D, okay, that was 1D, 2D, what about 3D, 4D, 5D? Whenever we have more than 2D, we normally call tensor. So the name of this package that you will find as TensorFlow, it's based on Tensor because this is the package which can provide you and which is mainly used for playing with tensor data. Because in the industry, there is a very huge demand. Like normally, you find the data in more than 3D, 4D, 5D. So that is a big challenge in the industry. So to handle that thing, we have this package in which we are calling TensorFlow. So this is tensor. Here you can find, let's here we have more than 2D, right? So we have variables, again, the same story. I have attached that link as well. No changes, only the difference is that in constant, we were not able to change the value, while in variable object, you will be. I give the example, like in case you have employee ID, which will be the same in the, in your records, you don't want to change anytime, you will make that column as constant, or you will add those value in the variables as constant. While in this, we have variables. And in the variable, we want this object should be changeable, right? So right now, same story. Once again, only the changes here, we have variable instead of constant. Again, you are going to get the shape. How many records are there? I mean, so what is the shape? 2 rows and 3 columns, right? We have 2 rows and 3 columns. Since we have one dot, that means it was a floating point value. And float 32 is default one. And the numpy again holding the same course. Right? Not a big deal, the same story. In case you want to access this TensorFlow.numpy, we got that result. You says, okay, can I access the shape only? You can do that. We got shape only, 2, 3, right? Same as if you says about dtype only, we got float 32. That was a default one. In case you want to change that float or the dtype, we can also do that. Now, okay, we have our TensorFlow object with us, right? That we have already seen here. In the previous one, we were able to find this is my TensorFlow object, which hold all the values here, right? This is my TensorFlow object. And in this, we can find we want to change a specific value in the variable. So this variable is here in which I want to change the or assign a new value here. So for example, we want to do, we have discussed like mainly we use these things in images, right? So whenever you get that images, like this is one image, right? Normally what you do, we have that kind of a bigger images. For example, 768 into 2 or 1024, right? So normally we get that thing in 3 colors. Even I will have that image in the bottom as well somewhere where I have just included that thing. Not, you can find this is a single image, right? 224 into 224, a small image is here, right? But when you see at the back, you will find RGB, red, green, blue. The 3 colors are there. And whenever you will convert that image into the vector form, you will find that kind of thing. And now you need to do a lot of different calculation. If you are going to start each and everything from scratch, you want to develop your deep learning algorithm, you need to know how to calculate. You need to do a lot of mathematical calculations, sometimes need to add the padding. You want some extra space here. You want to do processing. You only want to get some particular object. And after that, you want to use that data for training purpose, and many other use cases can be there. Again, many times you want to make the 1 or 0, just like especially in these kind of cases, we have images, we need to add some extra padding because we want to process. We will discuss about that thing in CNN. So, but right now we want to add something and you want to add random data. So during that time, we want only tf.once. I want to get a simple matrix of 10, 7. That means 10 rows and 7 columns with each one value. Can you find that? We have the 10 rows and 7 columns. Once again, the shape is 10,7. Since by default, it gives you float 1 point and the actual values are there. Same as you says about 3 rows, we will have that. 3,4, 3 rows and 4 columns, right? You says about, okay, can you please provide me a range? I want to generate a value from 1 to 25. So we have NumPy. In NumPy, we used to use this np.arange. In the Python, we first discussed like what is range function only, right? When you say range function, so it just provide you 1 to 13. But in case if we want to get 1 to 23, sorry, not 13. So in case you want to see, we need to convert that one to the list object, right? We used to talk about that stuff. That was range earlier. In the Python, we discussed. Where is that? Here. So here we were discussing about in the Python range was there. Then after in NumPy, we got a range. Now in NumPy also, we can also use to first convert this ND array object. You can find with this np.arange, that means you are going to generate some result from 1 to 24, and you want to convert this NumPy object into Tensor. And to convert that one into Tensor, we need to go with tf.constant. Right? Sorry. We have tf.constant, and we want to convert this NumPy into Tensor object. In the first one, we had 24 record with us. In the first one, we mentioned this A should be of 3,8. That means 3 rows and 8 columns. Please check it out first. A. I'm just broadcasting the value A. Now you can see we have 3 rows, 1, 2, 3 rows, and 8 columns. By default, all the value of NumPy, which was from 1 to 24, have been adjusted into, reshaped into 3,8, 3 rows, 8 columns. We got all these things, right? But now you says, okay, you have just converted that one to 3,8. What about B? In B1, you are not talking about any shape. It will be same as it is. Like there is no any shape. So by default, you can find 24 comma. Just like the same. I repeat what I was talking. First of all, I was just trying to show you, like here we have the NumPy object with us, np.arange. We got some data, 24 items were there, and we converted those 24 items into 3,8 shape. We can do that. In the next example, you were not saying to convert that one in any of shape. You said be tf.constant. You only converted any NumPy object into TensorFlow, Tensor object. We were able to do that, right? We were able to do that. Only simple records were there in 1D. Same as indexing, like you have this 1, 2, 3, 4. You want to get your indexings. Like what it means, like normally when you play with the normal list, we say starting from 0 by default. If nothing is mentioned, you want to get up to 2. That means 0 and 1. 0 and 1 means on 0th location 1 was there. On first location it was 2. We got that. The same process is here. Here you're talking about colon 2, colon 2, colon 2. That means you are going to take the first 2 record of each axis. So we got like that. 2 record of each axis. So this is again some mathematics, simple mathematics, what you want to access. But important thing, colon works again same as we normally do in Python, NumPy, and in Pandas. And now the same is in TensorFlow as well. Only you just need to use column here. The same thing, and shape and this, I repeat it. Now, if you want to perform some operations here, we can also do that here. Simple tensor is here. And in case you want to do some addition or different shapes, you can do that, right? So we can do that. There we want to do the addition, subtraction, multiplication, all the things can be done here. So right now we have tensor, just like as we discussed, like here we have the tensor with us. This is 1, 2, 3, 4. And now you say to add the scalar value, we can do that. Instead of 1, it becomes 3, 4, 5, 6. we are going to include 2 in each element. With that, if you say to do multiplication of it, you can also do that. Here we got multiply 5. With each element, you will be multiplying because actual tensor was 1, 2, 3, 4. Right? It was 1, 2, 3, 4. We got that. And now we are going to multiply with 5. Not a big deal. 5 on the 5, 5 to the 10, and then after so on. Right? We got that. But whenever you will see this tensor alone, it will be same because anywhere we have not assigned this value and we have not updated the object. That's why tensor is still same 1, 2, 3, 4. Right? Now you want to get the square of it, of each element. We will get that square of each element. Or in case you want to get the square root, that means you want to get the square root of 1, square root of 2, 3, 4, 5. You will get that. Normal and very basic operations with your tensor. Still, I think like I repeated that thing, but here we have multiply. So in case you want to use multiply, you want to use add the symbol or dot symbol. So we have various things to perform this multiply. One of them is simple multiply here, tensor, 10. So here you want to multiply with 10 value. So we are using this simple method. Which method? Multiply method. So this was the thing, 1, 2, 3, 4, and you are going to multiply with 10, and we got 10, 20, 30, 40. Right? We got that tensor. Now, but we have a little difference in matrix multiplication. I hope you are aware about the difference between the two. So in this, we are multiplying with each element with 10 here. But whenever you have tensor and tensor, you want to do this matrix calculation, we have a little different rule. So here, 1, 2, 3, 4 was your main tensor. In this one, you got the output as 10, 20, 30, 40. But in this one, you got the output as 7, 10, 15, 22. How it happened? So we have the different way of mathematical calculation. I hope you will remember that, like how we normally do the mathematical calculation of your matrix. I see somewhere here you can find like this way. 1 into 7, 2 into 9, 3 into 11, and you add all of them. You got the first element as 58. Right? So there is a little difference in this matrix multiplication. So in case you want to do, you will find in this case, we have the different. When you do this tensor into tensor, while matmul is different. If you want to do the same thing, you could also use add the same symbol. That means it will be same as we did matmul or add the, as I mentioned earlier as well. Right? We have this matmul, mathematical calculation, matrix multiplication, or you use add symbol. So both are same. Right? Simple mathematics. And now you want to change the data type of tensor. We have this TensorFlow, but now I have this TensorFlow B is here with us. So B is here. B data type is by default float because we have taken that value 1.7, 1.7.4. You can find this is float 32 only, right? But now whenever you would like to change the type of it, we have taken one more by default. So this C is integer, right? Above B is float, C is integer. Now you says I want to cast this. So tf.cast, you want to change the type of this B into float 16. You can do that. Simple. You are saying tf.cast, one way was there. Like whenever you're going to create during that time, you could say dtype is this. You could give that value dtype equal to float 16. We could specify here only, right? During that time, once you will do, it was only float 60. But in case if we are not giving, by default, it takes float 32. Please pay attention. And now you are saying, I would like to change it. I would like to typecast after some calculation, not a big deal. So you had that TensorFlow with you, Tensor object with you, as this whose dtype was float 32. And now you are going to change this B into float 16. So you can do that. Now you can see it have been changed into float 16. Same as we had this B, C, it was there 7, 10. And by default, when you will see these values, the dtype will be in 32. Just for clarification, I'll make it comment. The dtype was in 32. Now you also want to typecast into float 32. So that means 7 value should be 7.0, 10 should be 10.0. Please check it out. We got 7 point, 10 point. Right? How we did that? tf.constant. Right? I hope these things are very easy, not a big deal. We have already discussed much thing here. Now we have the string as well. Like in case you want to take the string, you have TensorFlow as your constant value. You want to get the length of it. Let's say 10, right? You want to take something again, we got 11 because I included 1 byte space. This is I will have a list of different objects in string form, not a big deal. It is just like a simple list object, and you are going to convert that list object into tensor object. So we have 3 elements are there, right? dtype is by default string because string is here, and what are the actual values that we can get. In case you want to extract all of them by using for loop, we can extract by using for loop. Like it will pass each element in the string, and you are going to print each tensor one by one. The first one was TensorFlow, second is deep learning, third is AI. With this, we are all done for TensorFlow. Please check it out. This is the fundamental.
So today we have covered the fundamentals of TensorFlow, how to import it, work with constants, and perform basic tensor operations. We also touched on key concepts like tensor shapes and data types, which are essential for working with machine learning models. So now it's your turn. Try implementing some of these basic operations in TensorFlow on your own. If you have any questions or run into issues, feel free to leave a comment below and we'll be happy to help you out. And don't forget, if you want to learn more and take your AIML skills to the next level, sign up for our free masterclass. It's packed with valuable insights to help you land high-paying roles in AI and machine learning. And if you enjoyed this video and found it helpful, please do hit subscribe for more easy to understand tutorials. Thanks for watching and make sure that you watch this video next.